Hello, Afton High School. How is everybody doing on this fine day here? So hopefully you are having a good day. I'm having a good day. So with that, if there are some issues with this video, if it starts cutting out or anything like that, please go ahead and email me directly, and I will either A, remake this video, or B, try to tech fix it. There just seem to be some issues with YouTube and all that. So today, we're going to build on the things that we already talked about with midpoint and distance. So the ideas of what we already talked about remain the same. The idea of midpoint. Now, we said length because, as I said in the previous video, I tried to reserve the word distance for when we're dealing with the Cartesian plane. Now, when we talk about the Cartesian plane, it's just called that because the guy who kind of came up with it, Rene Descartes, threw his name on it. But the Cartesian plane is just simply anytime we're talking about the idea of x comma y, that's the Cartesian plane. That's all that it is. Anytime we have an x-axis and y-axis, that's what it is. So again, it's just a fancy math term. I like throwing it out there. It sounds cool. So if we have a problem like this right here, and we want to find the midpoint. Now we could just maybe guess, and maybe looking at that picture, you can go, well, I think I know where it is. But we want to make sure that we're accurate. In math, we always want to make sure we're accurate. We don't want to say, I guess that's it. We want to make sure we know for a fact that that's it. So luckily, we have a midpoint formula. So if I want to find the midpoint, given 2 points. So I'm just going to write this generically, then we'll look at this one exactly. So if I have 2 points, some x1 comma y1 and some x2 comma y2. So if we just have these 2 points, any 2 points, our first point, our second point, that's what those ones and twos just represent there. So we have a formula. It is x1 plus x2 divided by 2, comma, y1 plus y2 divided by 2. All we're simply doing here is averaging the x's and averaging the y's. But right here, this is the formula that we need. So with that, I can go ahead and identify these points. This point right here is 5 comma 4. This point right here is -3 comma -2. And now we can just do that math there. So I can go ahead and 5 plus -3 divided by 2, comma, and then -2 plus 4 divided by 2. Now, I did this kind of intentionally here. The order you write those in doesn't matter. Since it's addition, it doesn't make a difference. I was like, so if you said this guy plus this guy, that's fine. If you said this guy plus this guy, since they're getting added together, order doesn't matter. So that's the big thing. That's why I wrote it here. So it doesn't really matter who you call x1 and y1 or who you call x2 and y2. As long as you just say, hey, these numbers are the x's, these numbers are the y's. X's are first, y's are second. Then we just do that math there. 5 plus -3 gives me 2, and then 2 divided by 2 gives me 1. And then -2 plus 4, well, that's 2. 2 divided by 2 is 1. So we know the midpoint is 1 comma 1. So, and if I happen to look right here, yeah, that looks like it's about the middle of that. And now we know that this distance right here would have to be the same as this distance right here, and we can do all the same things that we did with midpoints prior. Now, I always try to point this out with students because for some reason, instead of a comma, students try to add that number. For a midpoint, they give me 2. Does that make sense? If I'm asking you for a point, a midpoint, you should give me a point. That's the only thing that makes sense for what you were trying to give me. So that's what I always try to stress to students, is that when you're looking at these problems, make sure that in fact you are giving me what I am asking you for. All right, let's see that screen kind of washed out, so better. Okay. So now find the midpoint between 7 comma 8 and -13 comma 23. Let's look at those points first. I don't want to graph those. I don't want to graph 7, 8. I sure as heck don't want to graph negative 13, 23. That's the nice thing about the midpoint formula, is I don't have to have a graph. All I simply have to do is just use the formula. So as long as I know that formula, then I'm good. So I take my x values. Oh, there's an x. And there's an x. I'll underline that once. I don't want to underline that twice. So I'm just going to go ahead and say 7 plus negative 13. Put that over 2, comma. There's my y. There's my y. 8 plus 23 over 2. Sorry, I should have told you to pause that and then go ahead and try that problem on your own. Sorry about that. But go ahead and I simply just use those formulas. So 7 plus 13, that's going to go ahead and give me a negative 6 divided by 2. I end up with 3, comma. And then over here, 8 plus 23 is going to give me 31 over 2. That's not going to divide evenly. That's okay. If we were in class and everything was the way that I would want, I'm just going to write these answers over here, and everything, I would just tell you guys, hey, you know what? That's a good answer to me. 3, comma, 31 over 2. Here's the problem. I am going to have you type these answers. These are numerical answers. I do want them on, I do want you to type these into Canvas. Canvas doesn't like fractions. It's a problem I have, moving on past it. So this is the one time I'm going to say, hey, you know what? Go ahead and change it to a decimal. Again, I would always prefer this fraction. I'm going to tell you guys right now. 31 over 2, way better than a decimal. But this isn't a bad decimal, at least. If this was some crazy number, then we'd have an issue. But since it's not a bad decimal, I can just go ahead, and I'm okay with you guys just writing this as 3, comma, and then that's going to be 15.5. Like I said, normally I would tell you this is way better, and we're going to kind of see that throughout the year why those fractions are better. But you know what? There's going to be times where just we got to do what we got to do. All right. So now let's talk about the distance formula. So I want to know if I'm starting at this point and I'm walking to this point right here, how far have I walked? That's what I want to know right now. So luckily, again, we have a formula for that. We start off with the same. We need 2 points. You got to have a distance between 2 points, a start and an end point. So some x1, y1, and some x2, y2. So with those 2 points, we have a formula that can help us out. The distance simply equals the square root of x2 minus x1, quantity squared, plus y2 minus y1, quantity squared. So this is nice. I was like, this is nice right here. That's our formula. Again, I'm going to just highlight that for us. And now, so we had 2 formulas that we covered today. Whether we were apart, whether we were together, here's what I tell you, is that I don't make you guys memorize these formulas. All right, so with this right here, you would have had to have gone ahead and I was like, you wouldn't have had to have memorized these. I would have wrote these on the board for you. So just whenever you're taking your test in a few weeks or whatever, just make sure that it's like you got that taken care of. So right here, these are the same points from earlier, 5, 4, and then this one was -3, -2. So we have the same points that we had before. And now I'm just going to go ahead. Again, it doesn't matter which one you call x2 and which one you call y2. Again, just make sure you have identified the x's. All right, so I need 5, let's say the square root of 5 minus -3, quantity squared, plus Now, this is subtraction, so normally the order would matter, but because we're about to square it, I'm going to point something out, and I'll more so point this out on the next problem here. But I do want to stay consistent just for consistency's sake. So 4 minus -2 quantity squared. So minus a negative, that's the same as plus a positive. So that's going to give me 8 squared plus 6 squared. So 8 squared plus 6 squared, I end up with 64 plus 36. Now there's one thing that students forget, because they start doing the math and everything there. It's all inside of a square root, so we need to make sure that we remember there's still a square root there. And then 64 plus 36, we end up with the square root of 100. Well, the nice thing is that's a nice, pretty perfect square for us. The square root of 100 is, you got it, 10. And that would be our final answer here. We just simply go ahead and we have the answer of 10. So, not too shabby. Taking care of that. All right. So, any questions on the distance formula? Remember, I'm not here. It's a video. So, right here, find the distance between 4, 3 and 8, 1. So I want you guys to go ahead and try the distance formula real quick on your own. Pause this. All right, awesome. Thanks for coming back. So now let's go ahead and take a look at this problem here. So I'm going to have the square root of, again, I'm going to stay consistent here, 8 minus 4, 8 minus 4, quantity squared, plus, and then 1 minus 3, quantity squared. Now, there's a few things to point out, because there's a lot of little things that you can miss and forget about. 1, don't forget these are squared. 2, inside, we have minus signs. Inside those parentheses, we have minus signs. In between the parentheses, we have a plus sign. So make sure that all your signs are right. Make sure that when you're using this formula, you're using it right. So right here, 8 minus 4 gives me 4 squared, plus 1 minus 3 gives me -2 squared. Now, notice how I wrote this, because there's something I'm going to tell you guys. Something I'm going to tell you. I was like, I want you to take this to heart, so listen closely. Your calculator is stupid, okay? Because some of you guys might go, well, wait, Mr. Keith, when I typed this in, when I typed in -2 squared, it said the answer was -4. Yes, because your calculator is stupid. I want to make sure that it's clear as much as I can. Your calculator doesn't understand what you mean. If you don't type things perfectly, your calculator doesn't go, all right, I know what you meant. No, what your calculator is doing is it's going to square and then it's going to attach that negative. We do not have this. What we have is -2 squared. It is in parentheses. We have -2 times -2. A negative times a negative is a positive. I get a 4 right there. I get a 16 right here. Now, if you would have flipped these numbers and did 3 minus 1 here and did 4 minus 8 here, that's fine. Just the negatives over here on the 4. It doesn't matter. We're always going to end up with a positive 16 and a positive 4 in this problem. That's why I said the order doesn't, which one is x1 and which one is y1, doesn't ultimately matter because we're squaring it. So we have to make sure that we are paying attention. If you ever get negatives down here, you did something wrong. After you square it, you should never have negatives. So 16 plus 4 equals the square root of 20. Now, here's what I want to tell you, because I'm sure some of you guys are going, Mr. Keith, when I typed this into my calculator, it said it's 4.4 blah, 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 blah. First off, that's wrong. That's not what it is. It's close to what it is. A square root is what we call an irrational number. We can't actually express a square root as a decimal. We can get close. If you were to take that number that your calculator says, and you were to multiply it again, you were to multiply those numbers to each other, you're going to end up with 19.99999999999, or 20.000000001. You're going to end up with a close number, but you're not going to end up with 20. in this class, and really in all math classes, unless it tells you otherwise, we always want to be exact. So in that, we want to just leave our answer as the square root of 20. Now, in a later chapter, we will actually talk about what we can do with the square root of 20, because we can simplify that a little bit more. We're not going to worry about simplifying that right now, but that's just simply your answer. Now, in that regard, I want to make sure something's clear. I was like, when we have something like the square root of 20 here, I'm going to want you to type it into Canvas. Canvas isn't really letting you type in square roots. It bothers me, but it's not really letting you type in square roots. So this right here, I want to take a moment and just kind of talk about when we're using Canvas, how we're going to type things in. So I was playing earlier and I realized, all right, this is just what I'm going to have to do. Okay, again, this is just strictly for Canvas use. If we're talking about you're writing something on paper, I don't ever want you to do this. And anytime I'm asking you to do this, I'm going to make a note in there as well. And I'm going to talk about ordered pairs as well. I realized I didn't write that down, but I need to write that down as well. All right, so if we have a perfect square, if we have a square root of 9, I'm not saying don't use your calculator. That's what I want to make sure is clear. If you have trouble with square roots, if you don't know your perfect squares, you should. But if you don't know your perfect squares, again, that's fine right now. Square root of 9, simple, that's 3. Just type 3. I don't want you to not simplify a perfect square. All right, if you have 1, 4, 9, 16, 25, and so on from there, that simplifies. Give me the simplified perfect square. But if we have something like the square root of 10, all right, so if you're using your calculator, you type it in and you get some really crazy decimal. I was like, I don't want you to give me the really crazy decimal. The system will tell you you're wrong if you try to give me some crazy decimal. I'm not going to accept some crazy decimal. All right, trying to be serious here. I know I joke a lot. I don't want some crazy decimal. If the answer is the square root of 10, do you know what I want? I want you to type in the square root of 10. I just said, well, Canvas doesn't like these. So what you're going to type is this right here. SQRT, square root, parenthesis 10. So that's the big thing. Now, going back to those same answers there. So again, let's say that we had, I'm just making up some numbers here. Let's say that I had 7 over 2, comma, negative 5 over 2. Let's say we did the midpoint formula and we got that as an answer. As I already said, Canvas doesn't like fractions. You're going to need to give me decimals. That's fine. When you write an ordered pair, it's good habit to be in those parentheses. So yes, you will need to convert those to decimals, but for what you type into Canvas, I'm going to want parentheses, and then that's going to be 3.5, comma, and then hit the negative button, 2.5. For the sake of typing, don't leave any spaces. That's the other thing I'm going to say, is that when you're typing these numbers in here, when you're typing in that ordered pair, you're typing in that square root, make sure that there are no spaces involved. That's the thing that I want to tell you. Because if you were to go ahead and you hit parenthesis 3.5, parenthesis, space, negative 2.5, close parenthesis, Canvas is going to count it wrong. It's not wrong, but it's going to count it wrong. And it might take a few days for me to catch it and fix it. So that's just what I'm telling you, is make sure that you're just not putting any spaces in those. When I type the answer key, I'm not going to put any spaces. So make sure that you guys aren't. So make sure you have those two formulas, midpoint, distance formula, for when we're dealing with those ordered pairs. Like I said, I would just, at the top of your notes, I would write those formulas. Like even if you wrote them in your notes, just write them at the top of your notes and just go, okay, I need to make sure I have these ready whenever I know I need to do the midpoint or distance formulas. So, on that note, I will bid you adieu. Until next time, stay safe out there, Afton.